Hello, I'm Pieter du Toit, the developer of a number of fuel catalysts as well as gasoline. However, the combustion of a hydrocarbon fuel in an internal combustion engine is an extremely complex event encompassing many variables and far from being completely understood. The most important process, however, to ensure proper combustion is the perfect mixture of fuel and air, in addition to many other variables, regardless of whether it's diesel fuel or petrol fuel. Diesel fuel's physical behavior stands in the way of optimizing air-fuel mixture in diesel engines, and we have developed a way in modifying the behavior. Important to note, we modify the fuel's physical properties rather than the fuel's chemistry by means of a proprietary blend of fuel catalysts, ensuring a more complete combustion without any carbon buildup. Why is the combustion of diesel fuel not efficient? First of all, the late ignition period, and as the fuel will not start to burn until it becomes sufficiently hot. And secondly, once the fuel has ignited, it does not burn quickly enough. The fuel does not burn completely. If that was not true, then the product of combustion would only be carbon dioxide and water. No black smoke, no carbon monoxide, no unburned hydrocarbons, and no offensive diesel odors. No engine or exhaust deposits and lubricating oil of clean appearance, which is very important. This, however, means diesel fuel containing the product should allow a clean burn, and the very first result should be observed in the engine oil, which will retain its clean look without any blackening, while after thousands of kilometers it will still be as brand new. As time goes by, the exhaust pipe should have no more black carbon, but rather a clean appearance. In addition to this, the engine will operate with more power and a huge fuel saving with no more black smoke. It will have no negative effect, obviously, on the emissions reduction system or any carbon buildup, as the product is in the fuel to ensure a more complete combustion, which will reduce the formation of toxic gases. According to the EPA, about 68% of toxic gases are formed during a cold start, as the catalytic converter needs to be warmed up before it performs optimal. While laboratory results underscoring these claims have been done in addition to loads of typical application results over many years on brand new vehicles and other vehicles and equipment. The dirty air caused by diesel soot is more deadly than unclean water and malnutrition, according to a new research from a global policy forum. The study found that every year hundreds of thousands of people prematurely die to air pollution. A study conducted by Professor Jacobson from the Stanford University revealed that removing soot emissions from diesel fuel may have a faster effect on slowing global warming than removing carbon dioxide emissions. Chevron, as a major refinery, quote as follows: "The refinery really has limited control over the detailed composition of the final diesel blend. It is determined primarily by the composition of the crude oil feed, which is usually tested based on considerations of availability and costs, while chemical reactions that occur in the conversion process involve compositional changes. They are not specific enough to allow for much tailoring of the products. Yet, despite these limitations, refineries daily produce large volumes of on-test products. Truly a remarkable achievement." Close quote. Shouldn't there be something done to the so-called achievement to improve the typical characteristics of diesel fuel during combustion, ensuring a greener future for our planet, as we owe this to our coming generations? To address the issues around proper combustion, one needs to obviously recognize the characteristic of each type of fuel, be it diesel, petrol, or marine fuels. Considering petrol engine, especially in old vehicles, designated or designed rather to operate with leaded fuel, it is paramount to address the fuel's physical properties to ensure smooth operating results with maximum reduction in emissions. fuel savings and maintenance costs, and consequently the development of a product specifically for compression and for spark ignited engines. Heavy fuel oils, on the other hand, contains vanadium as a natural occurring element in marine fuels in soluble form, which means it will not be separated even when the fuel is treated in the centrifuge. Vanadium, when combined with sodium, can cause damage to the engine under elevated temperature. There are no practical methods by which vanadium can be removed from fuel on board ship. One operational solution for older engines which are sensitive to vanadium and sodium is the use of the fuel catalyst, which act as a combustion modifier. In conclusion, if we are serious in reducing the emissions, especially the black smoke, by means of proper combustion without any risk to mechanical failures, the solutions are available for right and proper evaluation.